Okay, cool. So we got. Actually, this is awesome for so many reasons, right? The screen's not going to be bouncing anymore either because it's not attached to the ceiling. Yeah, so we've got a full 1024 by 768. It's like XGA. Okay. So let's go back to that list again. Or, oh my God, the list can get bigger. Yeah. Okay. So the thing that we said was gonna be really cool about Hibernate, but isn't really cool about Hibernate yet, is that we don't really have any relationship between our entities, right? Right now, our contacts contain an address ID, but it's just an ID, and we don't really have a way of saying that it's a foreign key. And I mean, what we'd really like to be able to do is just anytime we get a contact, we should just be able to say like contact.getAddress. Just have that work, right? Like that should just work. We shouldn't have to go and look that up in another repository. It should just be able to get it directly. Right? And a related point is we haven't seen any joins yet, right? The fact that we've been using separate repositories and doing multiple queries, like I mean, that's inefficient. So this is the next thing that we're going to look at, and it won't actually take us all that long. I'm kind of trying to decide how to pace the rest of the day or what to do. Like we might just decide to kick off early and just have a little bit of a fuller day tomorrow. So sorry, just thinking out loud. Anyway, right. So we have said that we want a one-to-one correspondence between addresses and contacts, right? Right. Contacts should have an address. So what ideas do you have? What thoughts on this topic? Did we see anything that looked like it might solve this problem? Yeah, there's a one-to-one annotation. Right. Yeah, it's just 1, 2, 1. Right. All right. So 1-to-1. Right. So let's see. I'm not running.
How would it understand what that one-to-one would correspond to?
Yeah, how does it understand what it corresponds to? Well, let's find out. Let's see what happens if we try to run this.
You don't need to specify column.
Don't need to specify column. It's implied. But it's going to break, right? Let's make this a little bit bigger. One-to-one or many-to-one references an unknown entity of type long, right? Long isn't an entity in our system, right? Oh, just actually, I mean, since we've got the stack trace here, this is kind of like nice for the curious. You can see the entity manager factory impl is building a session factory, which is compiling some configuration information, and it's like it's doing all these checks, right? I'm just kind of like looking under the covers a little bit. It's kind of cute. But yeah, so long is not an entity. What is the entity? Address, right? Yeah. So here, let's. Yeah. So we don't want address ID. Let's say we actually want address. Right? We're going to actually contain an address. So let's go ahead and make that change. I mean, this is just very simple Java change here. So this dot address equals address. Oh, forget it. All right.
Why did we change that again?
So when we're specifying relationships between entities, we need the relationships between the actual entities, not the identifiers for the entities, right? We say a contact is going to have an address, and that's what we really want anyway, right? We want to be able to just say contact.getAddress. We don't want to have to say address repository.getAddress or address repository.find contact.getAddressID. Right? We want it to look like this. So this is how we specify that this is a relationship of some sort. It's one-to-one. Right? Okay, so let's run this now. Like this. And we're going to pay close attention to what SQL is emitted by Hibernate. Or we'll get a build failure. Oh, of course, yeah. Yeah, sorry, this doesn't run yet because we changed stuff. Right, this doesn't compile.
So the refactor would not automatically take care of the other stuff?
I did it by hand. I screwed it up, yeah. All right, so, right, address is equal to contact.getAddress. We don't even need, right? We don't even care. All right. And then same thing here, right? Contact.getAddress, right? When we construct a new contact, what's that going to look like?
Just pass it.
Just pass the address. And let's see. Contact.getAddress, right? All right, compiles now. So we're not looking the address up anymore, we're just getting it from the contact. We still need the address repository to be able to save the address, right? We don't have any way of doing that yet. So that'll be the next thing we talk about. But so far, when we want to get an address and we have a contact, we can just get the address from the contact. So that's the change that we're making. So let's try and run this. See if it runs. See if anything breaks. All right. Seems to have started up okay. Here, let's take a quick look at the DB log. Right. Oh. Yeah. There we go. So that works. All right. So what do we see? So create table address, create table contact, right? And those look the same as they did. Hey, how about this one? Contact. Contact has a field called address_ID. How did it know to call it that? Right, we had called it address_ID ourselves before, but it seems to have just magically figured that out now.
Just appended _ID to the.
Well, yeah. So the field is called address, right? So the field's called address, and what's the primary key of the address class? ID. Yeah. So _ID. Yeah. So it just constructed that column name for us, and then it says here alter table contact add constraint. It generates a unique ID for that constraint. It says foreign key address ID references address. Awesome, right? Sure.
Did you put the find method?
No. But let me show you what we've got. I'm sorry?
No, I just wanted to check if you updated that.
Oh, yeah, no, I haven't changed anything with that. Okay, so the database schema looks good. The database schema looks like essentially what we had before, right? Okay, so let's go, oops. So, hey, go back to our contacts list. All right, contacts, let's add a new contact. Where's my dog? Tesla. All right, there's Tesla. Back to contact list, Tesla. Yeah, that seems to work. That seems to work. Let's delete him. And uh-oh. Uh-oh. Start to have some problems.
Is it because you shut down one-to-one? So what we're trying to delete address.
Well, so it says we're removing something called a detached instance, which is a little curious. So we'll get back to what that means. Let's go back to the contact list. So that seems okay. So, all right. So, I mean, it's starting to seem okay. But we're not really using any of the benefits of what we've just written, right? Like, well, all right. So we'll talk about a few things, right? Let's make another little to-do list here. 1 to 1 to-do list. This is our things that we can benefit from having a one-to-one mapping. All right. So what have we done so far? Well, we can say, contact.getAddress, right? So that's good. We've got that taken care of. We can simplify our models for our front end stuff, right? Anytime we, let's see, in our, let's say view contact.jsp, right?
Contact.address.
Yeah, we don't actually need to pass address separately, right? We can just say contact.address.city, right? So simplify MVC model and view address can go away, right? We don't have to look up the address, right? So that's another thing, and then also what you're mentioning, right? We'd like to be able to just like, if we save a contact, it should save the address, and if we delete a contact, it should delete the address, right? So updated in some way, right? When I say updated, I mean like added, changed, removed, whatever, right? So the address should be updated as well, right? So a couple different things here, right? Your first assignment. Let me check in what we've got. Just again, if you want to do git pull in a second. Oops. So we've done this. Your assignment next is going to be just this simplification. Okay. This should be pretty mechanical. This one. Nothing too fancy.
So earlier we used to set attribute for address as well. You get method of contact server.
Yeah, it used to be we'd have to set the attribute to populate the model.
Right, but now I
Yeah, no,
assume
no.
that it wouldn't
Yeah, we
require
just
somehow
don't even need it.
delivery
Yeah.
address.
Right, yeah, our model for our contact pages is now just the contact. Makes sense, right? The contact contains the address. All right, this one's probably too easy. Let's just do it together. No. All right, am I recording? I am recording. Okay, fine. So I just recorded a whole lot of silence, which is awesome. Contact.address.street. So this, I can simplify this a little bit if I don't like typing out contact.address. I can do, I think it's like C:set var var equal contact, or sorry, address, and then value is equal to, man, I can't type at all. Contact.address, right? This is like, if I want to simplify my simplify my stuff a little bit. I don't know. This is just like setting a local variable, so I don't have to keep doing .get address. I'm not sure. Do I need to? Oh, actually, you know what?
Need to close it.
Yeah. Let's see if that works.
No, you need to have it enclosed, right? Just close it. It's
I think it doesn't work the way that you want it to. I think it doesn't define a scope like that. I think it's just in scope for the rest of the world.
I see, right.
I'm not sure. I think so though. Oops. Whoa. Sorry, I'm in a weird state, I think. Yeah, it works. I think anything that's inside the block is actually the value of the variable that we set. So, view contact, edit contact. All right, so we can do the same thing here. Right? Address is just contact.address. Let's put it here. Contact list. Well, we don't need addresses, so that's fine. And then add contact. We don't have any model, so that's cool too. Then contact servlet is the only thing that needs to change, right? So where we say, well, basically, we don't need to do contact.getAddress at all, or request.set attribute for address at all. Right, so that just goes in there. That was it, right? Yeah, I think so. Let's make sure. So we still have our delete problem. Which then puts us in a bad state, so I have to restart my server. Okay. All right. So so that's kind of neat. That was easy enough. That was not worth spending too much class time on. Okay. The real big deal is let's say we need to create a new contact, right? Let's take that specific case to start with. So look at contact servlet, do post. So for the add case, let's look here, right? So what's going on? What's going on with this? We're saving the address and saving the contact, right? And right now, I mean, we have to do that. We have to do it that way presently. I don't want to have to do it that way, but here's what happens if I don't. Right, so I'll take that out. Here's what happens if we don't. Let's run this again. Here we go, here we go. Back to contact list. Add a contact. And here we go. Error while committing. All right. So we're getting an exception. It's what's called a rollback exception. Actually, this is worth mentioning, by the way. When we get something called a rollback exception, there's two things that could possibly mean. So one thing is it means that we have to roll back. The other thing it could mean is that it has rolled back. Which do you think it is?
You need to roll back.
Let's take a vote. Need to roll back. Need to roll back the transaction. It has rolled back the transaction. I want ice cream. I don't know. Nobody's voting. Yeah. Man, I hate it when there's like nobody shows up to vote. Everybody register to vote, guys. Okay, rollback exception. So what it means is either it couldn't commit, so that there's nothing to roll back, or there was an error while it was committing and it rolled back the commit. So we don't have to do anything. That's the good news. The bad news is that there was an error, right? So this rollback exception says it was caused by illegal state exception, which was caused by a transient property value exception. This object references an unsaved transient instance. And so fortunately, it's giving us some information here. Check this little thing out. It says contact.address, which references address. Well, address is not saved. Okay, I mean that makes sense because we didn't save it. We want this to happen automatically. We'd like to be able to, if we have a new contact that contains a new address, and we save the new contact, we want the new address to get saved also. Right?
So do you need to call the address repository from the content repository?
It's even better than that. It's actually much nicer than that. Yeah, we don't have to worry about the address repository at all. Sorry, I'm feeling paranoid about there we go. Okay. Yeah, we don't have to worry about the address repository at all. There's a way to tell Hibernate to cascade the save. So this is the new concept that I wanted to introduce here, something called cascades. Okay. Let's look at our entities. Let's look at contact, right? This one-to-one mapping, well, it's a mapping. It specifies a relationship between several things. And so, so Hibernate knows about this, right? We said that the problem before in our code was that relationships weren't explicit, right? They were implicit, and we just had to sort of figure out how to do the right thing. And in our case, in our two-entity system case, it was obvious enough how to do the right thing. In general, it's not necessarily all that obvious. So if we make it explicit, then Hibernate can take care of it for us. This is a one-to-one mapping, and we can say cascade is equal to, and there's a few different cascade types. So cascade type, all, detach, merge. So basically, these are the operations that could be cascaded across this relationship.
Choose more than one?
We can choose more than one, and if we want to choose all, we can just say all. That's a placeholder for all of them. So for example, if we want to, well, what are we doing, right? What operations are we doing?
Delete. Update and delete.
Yeah, update and delete, and the update is merge. Yeah. Remove also, so merge and remove.
And refresh maybe?
Refresh, we're not doing refresh anywhere.
Where would refresh mean find, right?
No, refresh actually, refresh is actually explicitly like telling Hibernate to forget everything it knows about the managed entity and get a new one from the database. So
What
for
was the difference between persist and merge again?
I told you I'd tell you later, right?
Yeah, this is later.
Yeah, I'll tell you later. Yeah, I'll still tell you later, maybe. Well, no. So persist always creates a new entity. Always creates a new entity, right? I say persist, and it takes that object that I've given it, and it makes that object managed.
So it forgets about the ID if I've set it?
Doesn't
No, it'll use the ID if you've set it. Well, if you have a null ID, then it'll generate a new one still. So persist would work for what we've been doing. For add, but then for edit, we'd have problems.
Why? We're giving him the ID, right? We set the ID to the contact class.
Oh, that's true. It might actually work in that case. It's still generally a bad idea because of cascades. For example, if you add a new... I'm trying to come up with an example of where it would break. I'm too brain dead right now to think of a good one, but... Don't ask me tomorrow, man.
I have a question about the same ID.
Yeah.
If you have two entity managers,
Two entity managers, yes.
two different threads,
Mm-hmm.
and they're both trying to persist the same object, the same kind of object.
Uh-huh.
So now the ID, which is basically obtained by the entity manager, does it actually check with the oracle or whatever underlying?
They're thread safe. Since the IDs are coming from the actual database.
So every time you do a persist, it actually, or every time you do a first persist, it kind of like gets a batch of IDs. The entity manager gets
No, it doesn't get a batch. It does it for the specific entity that you're persisting.
Okay.
Right. And it populates that one, and that's basically atomic. Right. It expects to do that in a single database operation. So it's as if we've synchronized. It's basically as if it's in a synchronized block, except for we're synchronizing on the database instead of synchronizing on.
So what I used to think is like the entity manager will not contact the DB till you do the commit.
Correct.
Right. So if persist is actually contacting the DB to get the ID, that means there's a one round trip over there.
Yeah, there's a round trip. But it still won't happen until we do commit.
Okay. Because I used to think like they in fact somehow they batch a particular set of IDs per entity manager, so that there's no round trip involved every time you do a persist.
I don't think so. Have you read that somewhere?
Right. So
I
persist it actually doesn't go to DB as the normal thing which is said, right? Persist doesn't push out things to DB. Commit push.
commit does, yeah.
Right. So I'm kind of like thinking, how does it get the ID? So if it's getting an ID, that means it's actually making a round trip with the DB and getting an ID.
When you commit, like the object won't have an ID until you commit.
If you look at the object after em.persist,
Mm-hmm.
it will have an ID.
Mm-hmm. You might be right. Like I said, I'm feeling a little brain dead right now. Yeah, you might be right.
Let me know, like, if you can check it up tomorrow.
Yeah, I'll see if we can figure it out. Anyway, so all right, so since I'm so brain dead and I'm going to forget to come back to it, what I want to do, just to keep things very simple, and this is usually an okay thing to do, is just to say cascade type is equal to all, right? Anytime I do something with a contact, I want to make the corresponding update in that contact's address. So let's go back and try to add this contact now. There we go. So that seems to work okay. Edit the contact. Oh well, we haven't made the change to that part yet. Contact. Here we go. Contact servlet.
We're fixing the crash for the delete, right?
Yeah. We fixed the crash for the save. But it should also fix the crash for the delete. Let's make sure. So I'm just going to go from top to bottom here, and then probably what I'll let you do. Probably what we'll do is just I'll let you go because I'm feeling too stupid to do any more work. All right. So in do post for our contact servlet, so add now works, right? If we look a little bit more closely at the code here, right? We construct an address, we construct a contact, we save the contact, and we're done, right? Okay, how about edit? Request get parameter ID. So we get the contact, we get its address, and that's fine, right? Set the name, set street, city, state, zip. Save the contact. We should be able to just save the contact, right? Then delete. How about delete? Yeah, again, like, I mean, we shouldn't even need to get the address now.
Yeah.
We don't even care about the address. Just get the contact and delete it. Hopefully, that'll do the right thing. So let's see here. Let's edit this contact and delete it and see what happens. All right. So we get an empty contact list. It fixed the crash, and I want to go and look at the database. And sure enough, the address was deleted as well as the contact. Right? So good news. That's cascades, and cascades ideally are as simple as that. We can get into some trickier situations, which, like I said, I'm feeling too stupid to talk about at this point. But that's the idea with cascades. If we have a relationship between two different tables, then we can cascade operations that occur between them. All right, so if contact is updated, then address should be updated too. So that's right. Updates, deletes, edits, right? So that those are all taken care of. Let's add a new Tesla. Edit this. Yep. Yeah. So this is all working okay. So nice, even less code, right? We don't have to touch the address repository explicitly very much. As a matter of fact, as a matter of fact, if we go back to the, yeah, here we go. See this little, this little warning icon right here? I was expecting to see this little warning icon, meaning this address repository is unused. So this kind of makes sense, right? We expect that in the contact servlet, the controller for dealing with contacts, that we don't need an address repository. The contacts controller is going to deal with the contact repository. That's a pretty general pattern in this style of web development, right? Your controller for dealing with a particular type of entity will have the repository for that particular type of entity, and probably not much else, right? So it's good. We're managing to simplify this code somewhat. We still have this problem where do_post does like 4 different things. Do_get does a couple different things, but it's starting to come together. It's starting to make a little bit more sense. Now, there's one slightly unfortunate thing about our database log, which is that the only thing that we can see in it is updates. Right, we can't see queries that were performed against it, and I think there's some way that I can tell Hibernate to like dump output to the to standard out, and I think I want to be able to figure that out for tomorrow, so I'll make a note of that. But yeah, it's in persistence.xml. You know what? Give me just a second. I'll see if I can find it because I do want to be able to show the joins happening or not happening depending. Okay, so give me just a quick second. Right, in some situations in our code, you want Hibernate to do a join, and in some situations you don't. And we don't have a good like fine-grained control mechanism for this, but that is, we can't really choose on a case-by-case basis, but we can kind of do the best we can overall by choosing a fetch strategy. Okay. So let's talk really briefly about fetching strategies and then go home. All right. So here's some examples. Go back to the contact list here, and I can see my dog, right? And since I'm dumping the raw, basically the raw JPQL. This is sort of Hibernate's internal mangling of this stuff. We can see that even though I don't need addresses, Hibernate presently is fetching them. Right? Let's add a new contact. Foo. Add back to contact list. Right? So you can see a few things, right? Hibernate will so insert into address, insert into contact, and you know, here's some selects again, right? So we're selecting a contact, selecting address. Wait, here, let's reload. Oh, this one's doing okay. Actually, this is the, oh no, this is fine. Sorry. Yeah, this is totally fine. So, what fields is Hibernate looking for? When I just look for the list of contacts, right? The list of contacts, we only need the contact. We don't need the contact's address. So, Hibernate is saying, okay, select contact.id, contact.address.id, and contact.name, right? So that's like select star from contact, right? It's not going to the address table, right? It's not doing some sort of join or anything like that, right? All right. What if I go to foo here, right? Foo. Well, here, wait a minute. You know what? I think I'm, oh, you know what? It's got it cached, I think. Let's edit this. This is totally misleading. Yeah, this is hugely misleading. I actually don't like what's being logged here. All right, I'm not going to rely on this anymore. This is totally not what we want. I want to see the actual SQL or nothing. But this other stuff is too misleading. All right. Let me talk about this a different way. How do I want to talk about this? JavaX persistence. Sorry, we'll get there. Package, fetch, type. All right, here we go. All right, so different fetching strategies, right? So we're looking at the contact list. All we need is just information about the contact. So we would expect that we wouldn't try to incur any additional penalty of doing a join. I mean, the join isn't super expensive, but it's more than nothing. In the case of the contact of an individual contact, though, of course, we do need to see the contact's address. So we'd want to join. We wouldn't want to issue two separate queries, right? Issuing two separate queries, that's way more expensive because you probably have two separate database connections going on or whatever. Okay, here's that basic column. So two different strategies. One is called eager and one is called lazy. Well, all right. So these should be sort of self-explanatory. Basically, if we say that a field of an object, a field of an entity, that is, a one-to-one mapping or one-to-many or many-to-one or whatever. If we say that we're going to eagerly fetch from that mapping, oh, I know how we can view this. All right, we're going to actually do this in the debugger. It'll be way more fun. If we say that we're eagerly fetching the target of that one-to-one relationship, it basically implies that we're doing a join. Right? It implies that we're not going to have multiple queries. We're going to have one big query.
Why is that? Oh, because it saves. It's optimizing it.
It's optimizing it, right? Right. It says we're going to eagerly fetch the result of this relationship. So we'll join on the ID, right? Lazily fetching says, well, maybe issuing two queries isn't necessarily that bad, because maybe that second query won't be issued at all, right? So fetch equals lazy in that case, right? The other thing that's worth noting that might spare me some embarrassment, because we'll see what this ends up looking like in the debugger, is that even if we say lazy, Hibernate might still eagerly fetch anyway, if it thinks it's worthwhile. Okay, so let's try this out. Well, first of all, what do you suppose is the default?
Eager.
I've got one vote for eager and one vote for lazy. I think the answer is it depends on the type of the relationship. Like, if, for example, you wouldn't want to eagerly load a one-to-many mapping. Eagerly loading a one-to-one mapping isn't necessarily a bad thing, right? Like, that's pretty cheap. So let's do a little bit of debugging. I'm gonna start this fresh. And I want to set some strategic breakpoints in our contact list servlet, right? Yeah, here we go. Actually, I'll just set a breakpoint and find all. Should be okay. Set a breakpoint and find all. No.
Yes.
Yeah, list. Oops. This servlet is better. Set a breakpoint here. So, okay. First time through, obviously, we're not going to see anything. I didn't even hit enter. I mean, okay, it's fine. Where are we? Did Chrome just prefetch for me or something? I don't understand. Whatever. Anyway, this will maybe illustrate the point. Let me step in. Sorry, step in. All right, so this is gonna return some sort of a list. Let's see. Step return. Oh, yeah. So I'm not saving it. Fine. So I've got to go and look in the request attributes. Because there's no way to get. Yeah, it's unfortunate. Sorry. Step over that. All right. So contacts, right. So that's empty. This is the first time around it's empty. So let's keep going. I know. Add a new contact. Tesla. Okay. Back to contact list. Here we go. All right. So attributes has a map containing a contact. If I can find it, this is the one issue with debugging into these things is I've got to always find the key value. Here's a contact. All right, there we go. Okay, so it actually loaded an address for us, right? We have ID, we have name, and we have address. And the address is fully populated, right? All right. So that would seem to imply that the default fetching strategy for this one-to-one mapping was eager. All right. Sorry, that took a long time. Okay. Let's try now making this. Let's try making it lazy now. Lazy. Again, Hibernate might eagerly load this anyway, just because it can, but we'll see. All right, so let's try doing this again. All right. Attributes. Attributes has nothing so far. Wait. Here we go. Here we go. Hash map. Some stuff. Contacts. Oops. Value. Contact. Okay. And interesting. So this looks a little bit different. Check this out. We have an ID, we have a name, but this address is address javasys3, meaning that it was instrumented. That this is a phony address. This is an object that was dynamically created through javasys, which, if we look at it, has null city, null ID, null state, and it also has this handler thing. Yeah, here. So this is what I wanted to be able to see. I'm glad that we've gotten here. Sorry, I struggled to get here, but this is the fun part. This javasys lazy initializer thing is what's going to eventually populate these fields if they're demanded. Right. So in this case, there wasn't a SQL join, right? This javasys lazy initializer, what's it going to do? If we call get city, for example.
Make a separate query.
Yeah, if we call get city, I'm not even sure if we can set a breakpoint, but yeah, I don't think I'll be able to set a breakpoint or a watch point on this thing because it's gonna disappear as soon as I let it go. But yeah, this handler is gonna go back to the database and make another query to populate the fields of the address. Right.
So you don't have to do programmatically anything to fetch.
Yeah. I mean, yeah. So I just said I want this relationship to be lazily fetched.
You don't always set lazy.
Well, I shouldn't always set it to lazy, right? It depends. So let's stop this and talk about it really briefly, right? Like how expensive is it in the case of one-to-one relationship? How expensive is it to eagerly fetch?
Joins are expensive.
Depends on the size of the table, right? If you have 1 million records, it's pretty expensive.
Well, okay. What are we joining on? What is it like if we were gonna write the SQL query?
Primary key.
Yeah. So we would do select star from
It's always going to return
address.
Return one field.
Yeah.
Join field is primary key.
From address and contact where
Address ID.
I don't know. It's something like that, right? So, and the contact is what whatever, right? So for each contact, well, how expensive is it to look up a contact? Never mind address, right? How expensive is it to look something up in a database by its ID, by its primary key?
To read the index file, I mean, what
Depends
else
on
are
what
you-
kind of how it's implemented in the data.
Yeah, but basically, if you want to think about like big O notation or something, it's basically big O of 1, right?
It's one.
Yeah. Okay, so likewise, joining on a primary key. Basically, anything you do with a primary key is basically big O of 1. So this is going to be slightly more expensive, but not much more.
It's twice as expensive.
Yeah, it's big O of 2, right? Like this isn't a big deal. Okay. What if we had like a one-to-many relationship though? Then it'd be O of n, right? Yeah.
It's 3O.
Hmm?
It'll be 3O.
So,
O 3.
Which is
It'll
equal
still be
to
constant.
No, it'll be O of n, right?
if it's one-to-many relationship, if multiple, for example, if we said that a contact can have multiple addresses,
Oh, I see.
like a home address and a work address and whatever, then we have to find, well then obviously it's not going to be the primary key for address. Right. Address is going to have a field, or is like the way it's going to work if it's one-to-many. If contact contains
Array of addresses.
many address, what that would look like is we'd have a contact table, and it wouldn't have an address ID. Right? It'd just have it'd have its own ID and name, and then address would have an ID and city, state, etc., and a contact ID, right? So
Then you have a contact address table.
we don't have to have a join table. If it's one-to-many, we don't have to have a join table.
Yeah, but if it's many to many.
If it's many-to-many, we do, right? Right. So if it's one-to-many, and we'll see one-to-many relationships tomorrow. Then if we wanted to say select star from
Contact ID could still be indexed, right?
contact ID is indexed, but we have to find all addresses that have this contact ID. Oh, you mean sorry, you mean it's another index for this table? Oh, that's true. That's true. Yeah, you could optimize that way. So it'd be faster.
It'll still be constant time, right?
Linear. It's still linear time.
Linear as in the number of records retrieved.
Exactly. Yeah. Linear in the number of records retrieved, not linear in the size of the table. Yeah. Okay. Right. So basically, the point of this discussion is that if we say fetch type eager for a one-to-one relationship, that's really not a big deal. And that's sort of why it makes sense that eager was the default in this case. Right? Eager wasn't a big deal. What about if we said lazy? What are the performance implications? What are the performance implications of having a lazy fetch strategy for this relationship?
We have a blocking call. Right?
So blocking call, sure. Basically, anytime I load the edit page or the view page for a given contact.
And then there may be discrepancies in the sense of it's not an atomic read.
Yeah. So you could have issues with that as well, right? So concurrency can become an issue.
I'm sorry, how is it a blocking call?
Just because you have to go to the database and back.
You retrieve the contact and you don't do anything with the address, right? Now, when you actually go to fetch, access the address table, it'll be a blocking call until the data is fetched from the table.
Oh, you
Yeah.
enter it, but I mean from user's point of view, they will know that it's a blocking call.
Right. It's supposed to be transparent, right? I mean, but it's slower than if we had prefetched it.
Sure.
Right.
Actually, it wouldn't be a blocking call because for read, the row will not be locked.
It will go to the database, right? So anything that is I/O driven is blocking.
On the database side also?
Anywhere on the disk.
Yeah, basically, if you think is anything relating to I/O, like any file read, for example, or network call or anything like that, you think about it as blocking, even if it's not blocking for a long time. We can think of it as a blocking call. Yeah. So issuing multiple queries instead of just one kind of sucks. And probably the most expensive thing is if we need to reopen a new database connection. Like the call itself, once we have a connection open, that's actually pretty quick, right? Like, I mean, the query is quick. We know that. But opening a connection, creating a database connection, that's slow.
How slow is that? Milliseconds, microseconds,
Slow.
seconds.
Milliseconds. But I mean, it adds up. And it depends on your connection pool. It depends on if you have connections available, right? Yeah.
Also, it will take more resources, right, if you are to use a separate connection.
Yeah. So you would use a fetching strategy of lazy only in those cases where you don't expect you'll need the data, right? Make sense? Yeah. All right. So we'll see more of that tomorrow. Let's call it a day for now. But
So would you also go or explain the many-to-many relationships in this course?
yes. Yeah, and so we'll see basically how to make join tables and stuff like that, right? Yeah. Okay. So probably enough for today. We've seen basically this last chunk of work that we saw was to see cascades. Right, cascades make it so that if we're dealing with contacts, we just deal with contacts. We don't have to do some other magic to save addresses and stuff like that, right? Or to delete or update, right? So Hibernate is maintaining logical consistency for us there. And then last thing we talked about was these different fetching strategies. Okay. Any questions on that? I'll check this in as usual. Actually, there is one more quick thing I wanted to mention, just because it's screaming at me on the screen right now. This right here. This right here is calling my name. Like I want to talk about this default constructor. All right. Why do I need that? And for that matter, like, well, yeah, that's a good enough question to start with. But why do I need that default constructor for contact, for address, right? Why do I need those? Why can't I just use these reasonable constructors? Serialization, that's like getting there, part way.
So the default constructor, right?
Yeah. Why do I need these default
Because
constructors?
if you have already a constructor, Hibernate may use it internally, right?
Hibernate uses it. Yeah.
But Java wouldn't automatically generate that for you?
Not if you have your own
No.
constructor.
Yeah, if we have our own constructor, Java won't generate a default one.
That would be unlike C++, right?
No, it's exactly like
I think it's exactly yeah.
Some language that doesn't.
Yeah, it's been a few years for me since I've done C++, but yeah. So Hibernate uses these. Hibernate uses these default constructors, right? It uses a default constructor to materialize an object, and it also uses the setters, right? Yeah, it wouldn't work to just have the fields, right? I mean, some frameworks can actually do it. Some frameworks will just will just totally circumvent the access restrictions. So some tools are kind of crazy like that, but Hibernate doesn't do that. Hibernate requires you to have no arg constructor and setters for all your stuff, because that's how it materializes objects when it's unmarshalling.
I just one quick question.
Mhm.
So what if my entity class, I make all my setters as private? Would Hibernate still call it?
I think you might be screwed. Let's try it.
It calls it, so I just wanted to know how does it call it?
I don't know. You've tried it before and it works. It works. Oh, all right. Well, in that case, I won't try it. I'll trust you.
No, I don't know why it works, but
Yeah, well, so it's doing reflection,
Reflection,
and
yeah.
in reflection you can just say, oh,
One
set the permission to anything. Yeah. All right. Any questions on that? The reason I bring this up, this stuff about having a default constructor and having these setters and stuff, is that generally the coding style that I prefer uses immutable classes. I like all my fields to be final. Final fields, constructor that takes all the things that you need, no setters, right? I mean, that's a much safer style, sort of a functional style. But again, that convention goes out the window when we're using Hibernate. We have to follow standard kind of bean conventions with mutability and the whole slew of bugs that comes with it, right? All right, cool. I'll see you guys tomorrow. Yeah, the plan for tomorrow is going to be to make some more classes, right? Now that it's easy enough, we want to see some more classes in our system. We want different kinds of contacts. So we'll see inheritance and polymorphism in our database. Ooh, yeah. So different kinds of contacts and different kinds of relationships. So we'll see one-to-many, many-to-one relationships. We'll see inverse mappings, and we'll also start to see Hibernate, or we'll basically start to see where JPA becomes a pain in the butt. And that will provide some additional motivation for Spring for us. Okay? We won't really wrap it up per se, but we'll be more focusing on Spring on Thursday. Yeah. Might get, I don't know. I'll think about it.
Because I want to just make sure that we have enough time for Spring as well.
Oh yeah, of course. Yeah.